In this video, we're going to talk about how to reduce and optimize your compute costs on AWS. We're going to look at some simple AWS tools and approaches you can use to match your compute usage much closer to your actual demand, cut down your costs, and run more efficient workloads. Before we dive into specific AWS services, it helps to remember something. On-prem, you usually buy hardware to handle peak load and accept that it's underused most of the time. Many companies move to AWS by recreating the same big servers they had on-premises as EC2 instances. These are often sized for peak load, even though the workload changes over time. That mindset makes sense in the traditional data centers, but in the cloud, it leads to wasted money and resources. When you keep oversized EC2 instances running 24/7, you're paying for compute power that just sits there idle. That's bad for your budget, and all that unused capacity isn't great for the environment either. In the cloud, you can scale your compute resources up and down as demand changes. The key to saving money is to stop thinking in terms of fixed servers and start thinking in terms of demand-driven capacity. Let's just start with auto-scaling. Auto-scaling is about matching your compute capacity to your workload. Instead of running the same number of instances all the time, you place your EC2 instances in an auto-scaling group, and this group can automatically add more instances when demand goes up and remove instances when demand drops. You can think of it as a flexible pool of servers that grows and shrinks for you. For example, if you have a web app that's busier during the day and quieter at night, auto-scaling can increase capacity during busy hours and scale back down when things are calm. In that way, you pay for extra compute only when you really need it. Now, let's talk about right-sizing instances. Right-sizing means picking EC2 instances types and sizes that actually fit your workloads, instead of just using large instances just in case. You might find that several medium-sized instances behind a load balancer give you the same performance as a very few large instances, but at a much lower overall cost. For example, instead of using one huge instance at 20% CPU utilization all the time, you might use a smaller instance that runs closer to 50 or 60% utilization, and then scale out horizontally when needed. The goal is simple. Don't pay for CPU and memory you never use. AWS makes this easier because you can change instance types quickly and combine right-sizing with auto-scaling for even better efficiency. Next, let's look at reserved instances. Reserved instances, or RIs, help you save money when you have steady, predictable workloads. With RIs, you commit to using a certain instance type in a specific region for 1 or 3 years, and in return, you get a discount compared to on-demand pricing. This works well for things like production databases or core application servers that you know will run all the time. You have the option to pay all upfront for the biggest discount or spread payments over time. There are 3 main types of reserved instances. The first one is standard RI. Standard reserved instances are the classic option. You reserve capacity for a specific instance type and platform in a region, and you get the highest discount. This is a good fit when you know your setup won't change much, like a long-running application server. The second one is convertible RIs. Convertible RIs gives you more flexibility. You still commit for 1 or 3 years, but you can change the instance family, operating system, or tenancy later as long as the new option has equal or higher value. This is useful when you know you'll need compute for a long term, but you're not fully sure which exact instance type you'll use. The third one is scheduled RIs. Scheduled RIs are for workloads that only run on a specific schedule. You reserve a particular instance type for set time windows, such as a few hours every weekday night or 1 weekend per month for batch processing. For example, if you run a monthly batch job on the first weekend of each month, you don't have to pay for that capacity all month long. You just reserve it for the times you need it. Now, let's talk about saving plans, which are closely related to reserved instances but give you more flexibility. Saving plans help you reduce compute costs by committing to a consistent amount of usage over time. Instead of committing to a specific EC2 instance type, you commit to a certain dollar amount per hour for 1 or 3 years, and in return, AWS gives you discounted pricing compared to on-demand. The big difference here is flexibility. With reserved instances, you're locking in a specific instance type in a specific region, but with saving plans, AWS automatically applies the discount to whatever matching compute you're actually using as long as you stay within your committed spend. There are two main types of saving plans. First, compute saving plans, which are the most flexible option. They apply automatically across EC2 instance types, sizes, regions, and even across services like AWS Fargate and AWS Lambda. As long as you're using compute and staying within your hourly commitment, you get the discounted rate. This is a great fit when you know you'll have steady compute usage overall, but you expect your architecture to evolve over time. For example, you might move from one EC2 instance family to another, or shift part of your workloads from EC2 to containers or serverless. The second type is EC2 instance saving plans. EC2 instance saving plans are a bit more specific. You commit to an instance family in a particular region, but you still get flexibility across different instance sizes within that family. These usually give slightly higher discounts than compute saving plans, but with less flexibility. Saving plans sit right in the middle between on-demand and reserved instances. They're ideal when you have predictable usage levels, but you don't want to lock yourself into exact infrastructure choices for years. Now that we've covered reserved instances and saving plans, let's look at the lowest cost option of all, the spot instances. Spot instances let you use spare EC2 capacity at big discounts compared to on-demand, sometimes up to 90% off. The trade-off is that AWS can take these instances back with a short warning when the capacity is needed somewhere else. That means your workloads must tolerate interruptions. Spot instances are great for fault-tolerance tasks like big data analytics, background processing, or rendering jobs when you can retry or resume if an instance goes away. You get very low cost, but you have to design your applications so they're okay with interruptions. Next up, let's talk about AWS Compute Optimizer. AWS Compute Optimizer is a service that analyzes your usage metrics, for example from CloudWatch, and recommends better instance types and sizes. It looks at historical CPU, memory, and network data to see if your instances are underused or overused, and then suggests right sizing options. If you constantly use only a small part of your CPU, Compute Optimizer might suggest moving from a large instance to a smaller, cheaper one. This removes a lot of guesswork and helps you improve efficiency and reduce costs without manually digging through graphs. So far, we focused on EC2 and how to make it cheaper and more efficient, but there are also other compute services that are pay per request by design. Let's look at AWS Lambda. AWS Lambda is a serverless compute service where you don't manage any servers. You upload your function code and Lambda runs it only when an event triggers it. You're built based on the number of requests and the execution time. And when there's no traffic, you pay nothing for compute. This is very ideal for event-driven or unpredictable workloads, such as processing messages from an SQS queue, reacting to uploads in an S3 bucket, or running lightweight APIs where load can spike or drop to zero. Now, let's talk about AWS Fargate, another AWS managed service in this section. AWS Fargate is a serverless compute engine for containers. It works with services like Amazon ECS and Amazon EKS and lets you run containers without provisioning or managing the underlying EC2 instances. You define how much CPU and memory each container needs, and Fargate handles the scaling and placement. This is a very good fit for containerized applications where you want to keep the container model but avoid managing servers and capacity yourself. Before wrapping up the video, let's quickly go through a few quick pointers that ties these ideas together that you should remember. The first one is think demand-driven, not server-driven, which means in AWS, cost savings start with a mindset shift, stop sizing for peak and start scaling based on real demand. Elasticity is one of the biggest advantages of the cloud. Please make sure you use it correctly. Auto-scaling helps you handle changing demand over time, and right-sizing makes sure each instance you run is actually the right size to begin with, and with them combined, they can help you avoid paying for idle or oversized capacity. In terms of reserved instances versus spot instances, use reserved instances for known, steady workloads when you can commit at least for 1 or 3 years and one predictable savings, and use the spot instances for flexible, fault-tolerant workloads that can tolerate interruptions and benefit from very low cost. And you can consider using saving plans because they help you lower compute costs by committing to a consistent level of usage over time while keeping the flexibility to change instance types or even move between EC2, containers, and serverless services. AWS Compute Optimizer removes guesswork by analyzing real usage and suggesting better instance sizes. And you can also consider serverless services like AWS Lambda and AWS Fargate that naturally optimize costs by charging only when work is happening. They're ideal for when traffic is unpredictable or when you want to avoid managing capacity entirely yourself. And the most important one, there is no single best option in AWS. Always remember to mix and match based on your environments and setup. Cost-optimized architecture usually combine auto-scaling, right-size EC2 instances, RIs, spot instances, and serverless services. The goal isn't to use everything, but to use the right tool for each workload you have. Alright, that's a wrap for this video, everyone. Thank you so much for watching. Please make sure you're subscribed to our YouTube channel, and I'll see you in the next video.